Welcome students. In this video, I am going to discuss chapter number 10 straight line. Before I start the new topic, I would like to have a quick revision of previous results. The first formula is the distance between any 2 points, say x1 y1 and x2 y2, is given by root x2 minus x1 whole square plus y2 minus y1 square. Then the coordinates of a point dividing the line segment joining these 2 points x1 y1 and x2 y2 internally in the ratio m ratio n are given by m x2 plus n x1 divided by m plus n, and here m y2 plus n y1 upon m plus n. And if the division is external, we are going to have here negative sign. Next, the coordinate of a midpoints of line segment joining point x1 y1 and x2 y2 are x1 plus x2 by 2 and y1 plus y2 by 2. Next is the area of triangle whose three vertices are given. Say x1 y1, x2 y2 and x3 y3 is given by half mod of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Now the new topic in this chapter is inclination of a line. Just look here. This is your two-dimensional plane. A line in a coordinate plane forms two angles with x-axis which are supplementary. Clearly this line is making two angles with x-axis. The one is theta and another is 180 minus theta. The angle theta made by this line with the positive direction of x-axis, and it should be measure anti-clockwise direction, is called the inclination of line. And this inclination always is greater than or equal to 0 and less than or equal to 180 degree. I am again repeating, the inclination is the angle made by line with the positive direction of x-axis in anti-clockwise direction. So the slope of line or the gradient of line, if theta is the inclination of line, then its slope is given by tan theta. The second formula, the slope of a line which passes through 2 points x1 y1 and x2 y2 is given by y2 minus y1 upon x2 minus x1. Next is the condition for parallel and perpendicular line. If you have two lines here L1 and L2 which are parallel, if these two lines are parallel, that means both lines will make the same angle with the positive direction of x-axis and anti-clockwise direction. That means they are going to have equal inclination. Alpha is equal to beta. Taking tan, so that means m1 is equal to m2. So if two lines are parallel, they are going to have equal slope. Next, if two lines, say L1 and L2 are at right angle, means 90 degree. Now if this angle is 90 degree, this is also going to be 90 degree. Now from exterior angle property, exterior angle alpha is equal to sum of opposite interior angles. So that means alpha is equal to beta plus 90. Here alpha is the inclination of first line, beta is the inclination of second line. So from here alpha is beta plus 90. Take tan on both sides. You will have tan alpha is equal to tan of beta plus 90. This is 90 plus theta. Tan will change to cot. In second quadrant, tan theta is negative. So minus cot beta is minus 1 by tan beta. Multiply them, tan alpha into tan beta is minus 1. Or m1 into m2 is equal to minus 1. So from here you are going to have a result. If two lines are perpendicular, then product of their slope will always be equal to minus 1. First example is find the slope of line which passes through these 2 points. Now you can take any point as x1 y1 and another as x2 y2. So slope is y2 minus y1 upon x2 minus x1. 4 minus minus 2 divided by minus 1 minus 3. So this is 6 by minus 4 is minus 3 by 2. Next question. Find the slope of line making an inclination of 60 degree with the positive direction of x-axis. Now this line is making an angle of 60 degree with the positive direction of x-axis. So its inclination will be tan 60 degree. Inclination is 60 degree, so slope will be tan 60 degree. That will be root 3. Now first question from exercise 10.1. You have to draw a quadrilateral in Cartesian plane whose vertices are given and then find its area. Let ABCB be any quadrilateral with the vertices A, B, C, D. Here the first point is 4 minus 4, 5. This is your A point. B, 0, 7. X coordinate 0, so point will lie on the y axis. C, 5 minus 5. And the last point is D, minus 4 minus 2. Now join this diagonal. Clearly this quadrilateral is made up of two triangles. So the area of quadrilateral will be equal to sum of areas of these two triangles. So from your 10th formula, you can evaluate area of triangle ABC plus area of triangle ACD. So area of triangle ABC is half mod of minus 4. Then you have 7, sign will change, plus 5. This is 0. Here you have minus 5 plus 5, 5 minus 7. Take mod. Same for second triangle. When you are going to evaluate this, you are going to have negative minus 58. But we know that area is always positive. So we are going to have positive sign. This is 58 by 2 plus, again take mod. This is positive 63 by 2. So your answer is 121 by 2 square unit. Next question is base of equilateral triangle with side 2A lie along the y-axis such that the midpoint of base is at the origin. Then find the vertices of triangle. Now first of all, let A, B, C be any triangle, equilateral triangle. Equilateral means all three sides are equal. They are given to be 2A. Now the base is along y-axis. Let this be your base such that the midpoint of base is at the origin. Now if full length is 2A, this is your midpoint. Half will be A. This is also A. You have to find the vertices of these three. Now B point is on the y-axis. From here OB, OC both are equal to A. Right? And if you find the coordinate of B, it is on the y-axis. So x coordinate will be 0 and this is A. So 0, A. Same for C. X coordinate 0 and this is in fourth below origin y will be negative. So this is going to be minus A. Now you have to find the coordinate of A. A point is on the x-axis, right? So its y coordinate will be 0, for which you need to find distance OA. Clearly triangle OBA is an right angle triangle and this AB is 2A. So hypotenuse square 2A whole square will be A square plus OA square. From here your OA is root 2A square minus A square. So that is A root 3. So the coordinate will be root 3A 0. Now second thing, if this point A, let it be A dash, lies to the left of origin, that is not given in the question whether it is lie on to the right of origin or to the left of origin. Now if it lies to the left of origin, that means the sign of this will change. Coordinate will be minus root 3A 0. Next question, find a point on the x-axis which is equidistant from these 2 points. Now the point is on the x-axis, so its y coordinate will be 0. Let the point be A0. Now this point is equidistant from these two. Just apply the distance formula, that is root A minus 7 whole square plus 0 minus 6 square. Here you have A root A minus 3 square plus 0 minus 4 square. Now this root will be cancelled. Expand your square. This A square is also cancelled. So simplify them. That means your A is 15 by 2. So required point is A0. This is 15 by 2, 0.